Well, so here this is a Stokes theorem and its statement. Okay, the Stokes theorem statement is written like this, and now we shall go for that is examples. If f is equals to 3yi minus xzj plus yz square k, comma, and S is the surface of paraboloid. S is the surface of the paraboloid 2z is equals to x square plus y square bounded by z is equals to 2, comma, then evaluate double integration over a surface S del cross f dot n cap ds using Stokes theorem. Right? So this is the example. So here first we'll write what they have given. Let given is f is equals to 3yi minus xzj plus yz square k. Yes, you can call it equation number 1. Right? And now we know that what is dr? Dr is what? I dx plus j dy plus k dz. It is k dz. Now therefore what is f dot dr? That means the dot product of f and dr is 3y into dx. Negative sign is there, right? Negative, because here positive negative, that is negative xz minus dy plus yz square into dz. Okay, now I can call it as equation number 2 if you want, right? So now here they said this you need to find, right? That is del cross f dot n cap ds. Del cross f is nothing but what? That is curl f, you know, right? What is curl f? That is del cross f only, right? Instead of what mentioning that is curl, they have mentioned that is del cross f. So here we are finding del cross f dot n cap into ds. Okay, so double integration over that is surface S. So either you can use this or this, because this is equal to this means what? You can very easily use this. One can very easily understand that, right? So therefore here what I'll do is, first here I'll write by Stokes theorem. By Stokes theorem we have, what is Stokes theorem? That is integration over a closed curve C f dot dr is equals to double integration over a surface S, that is curl f dot n cap into ds. So now we know that's what curl f means what? That is double integration over S. Curl f means del cross f dot n cap into ds is equal to f dot dr. F dot dr value is already here, right? F dot dr is equals to 3y dx minus xz dy plus yz square dz. Okay, write it. Then integration over a closed curve C, right? That is 3y dx minus xz dy plus yz square dz, right? So this is, now you can call it as equation number, that is equation number 3, right? So now what is the surface? Surface is this paraboloid. Okay, surface is what? That is paraboloid. Then how you can draw that paraboloid? You can see here. Yes, so this we can call y-axis, this we can call x-axis, this we can call z-axis. Paraboloid is 2z is equals to x square plus y square. Yes, 2z is equals to x square plus y square. Then how it will be? It will be like this. Yes. Okay, so this is what the paraboloid, right? Bounded by z is equals to 2. So this is z is equals to 2. This is what? Z is equals to 2. Z is equals to 2 means there is a plane which is parallel to xy plane. Okay, z is equals to 2 is a plane which is parallel to xy plane, right? So now, so this is your paraboloid, right? So now here we can call it as, that's what, origin O, right? So now paraboloid. So this is a surface, yes, right? This is what the open surface, yes, it is not a closed surface, it is open surface, one can very easily understand. So this is what the surface, yes. What is the closed curve? Closed curve is this, yes, this is the closed curve C. Okay, that is what the closed curve C. So therefore here I'll write the given closed curve C is, that is 2z is equals to x square plus y square at where it is closed at z is equals to 2, which implies that at z is equals to 2 means we have to put z is equals to 2 here. That means 4. That means here I'll write 2 into 2 is equals to x square plus y square, which implies that x square plus y square is equals to, that is 4. Or else you can write it as what, that is 2 square also, right? If you write 2 square, then that means what? Radius is, this is a circle, okay? The closed curve is what? That is a circle, right? So closed curve is circle means its radius is 2. X square plus y square is equals to 2. We can write. So now the parametric form of circle x square plus y square is equals to 2 square is x is equals to 2 cos theta and y is equals to 2 sin theta. Therefore what is dx? Minus 2 sin theta into d theta, and what is dy? This is 2 cos theta into d theta. Also z is equals to how much? That is 2, which implies that dz is equals to 0, right? So dx is there, dy is there, dz is there, x is there, y is there, and z is also there, right? So now here you have that's what, yes, equation 3 you have. Okay, so that we have written there, right? Therefore equation 3 becomes, equation 3 one more point. Okay, not only this, here we need to write from where to where your x is varying, or else you can write about the theta. Okay, if it is a circle, then theta varies from where to where? Theta varies from, if it is a circle, then theta will be taking what, that is journey from theta is equals to 0 to theta is equals to 360 degree. Therefore we'll write theta varies from, theta is equals to 0 to theta is equals to 2 pi, that is 360 degree, right? Therefore equation 3 becomes, double integration over a surface S curl f dot n cap into ds. Sorry, so instead of what curl f will write, because they asked us del cross f. So is into ds is equals to, that is integration curl c. So leave it. C is what, that is C is a circle. So therefore, and it is running from theta is equals to 0 to 2 pi. So we are writing it in terms of what, that is theta. So theta is equals to 0 to theta is equals to 2 pi. 3y. 3 into what is y? 2 sin theta. What is dx? Dx is here, that is minus 2 sin theta d theta. Okay, next minus x. X is 2 cos theta and z is 2, because z value is 2, here it is there, z is 2. Next, what is dy? Dy is, that is 2 cos theta d theta, 2 cos theta d theta plus 0 I'll write. Why do you know? Because dz here is there, but dz value is 0, so therefore that whole term is 0. That is equal to integration from theta is equals to 0 to theta is equals to 2 pi, 2 into 3, 6, 6 into minus 2, minus 8, minus 8 times sine into sine into sine, that is sine square, that is sine square theta. Next, d theta we can take it common, then again minus sign is there, minus sign, 3, 6, sorry, it is 12, 2 3s are 6, 6 2s are 12, this is 12. Next, here it is 2 into 2 into 2, that is 8, 8 times cos square theta, okay, close the bracket and take d theta as a common, right? So now rearrange the terms. Theta is equals to 0 to theta is equals to 2 pi. So here what I'll do is, here I'll write 4 times sine square theta, I'll write minus 8 times sine square theta minus 8 times cos square theta into d theta. You can see 12 is there, minus 12 is there. So minus 12 I split it like this, minus 4 times, minus 8 times, minus 4 minus 8, that is minus 12. So now here double integration over S del cross F dot n cap into ds is equals to that is integration from theta is equals to 0 to theta is equals to 2 pi. So here you will get, so here if you take minus 8 common, then here you will get sine square theta plus cos square theta. Sine square theta plus cos square theta value is 1. So here now we'll get minus 4 times sine square theta minus 8 you will get, and here it is d theta, which is equals to minus 4 you can take common, then theta is equals to 0 to theta is equals to 2 pi. Then now here you will get sine square theta plus 2 into d theta, that is nothing but again integration from 0 to 2 pi. Sine square theta can be written as 1 minus cos 2 theta divided by 2 plus 2 into d theta. So if you take that minus 2 outside, then it is minus 4 by 2, then integration from theta is equals to 0 to theta is equals to 2 pi. Here you will get, this is 2 plus 2 into 2, 4, 4 plus 1, that is 5, 5 minus cos 2 theta into d theta, that is nothing but minus 2, then now that is 5 theta minus cos, integration of cos is sine, that is sine 2 theta divided by 2, then theta is from 0 to, that is theta is equals to 2 pi. By putting the upper limit, minus 2 in the bracket, 5 into 2 pi, that is 10 pi minus 0, and for lower limit it will be 0. This is minus this is 20 pi is the answer. That is double integration over S del cross F dot n cap into ds is equals to, that is minus 20 pi, that is minus 20 times pi. So this is a final answer. Yes, one can solve examples on, that is Stokes theorem like this. Yes, so now one more example on the same what the concept, that is Stokes theorem. Yes, example number 2. Example number 2. Evaluate integration over a closed curve C yz dx zx dy plus xy dz where C is the curve x square plus y square is equals to 1 comma z is equals to y square by by Stokes theorem. By Stokes theorem. Okay, simple example. Okay, not much difficult in it. There is what the closed curve. See, they have given as what that is x square plus y square is equals to 1. Okay, that is again a circle with radius as 1 in it, right? So now solution, so what they have given, just you write it, closed curve C yz dx plus zx dy plus xy dz. What is this actually? This you can write, that is closed curve C f dot dr, okay, if you want. Okay, because f1 dx plus f2 dy plus f3 dz. Okay, that's f dot dr. F dot dr will be like that one, you know, f1 dx plus f2 dy plus f3 dz. Okay, so you can say it like this, right? So now by Stokes theorem, we can write the same thing. I'll write it. That is integration over closed curve C f dot dr is equals to double integration over surface S curl f dot n cap into ds. Okay, so which implies that, so this one is equivalent to what, this, right? So therefore, which implies that I'll write integration over curve C f dot dr is equals to integration over closed curve C yz dx plus zx dy plus xy dz. Yes, you can call it as equation number 1. Both are on the same. You can remove it. Okay, so we'll call it as equation number, that is 1. Yes. So now, so given closed curve C is x square plus y square is equals to 1 and z is equals to y square. Okay, that they have given, so we'll write it. Yes, the parametric form of circle x square plus y square is equals to 1 is x is equals to cos theta, y is equals to sin theta. Do you know why? Because here radius is 1, so here radius is 2, therefore we have written 2. So here radius is 1, so therefore 1 cos theta is cos theta, 1 sin theta is sin theta. Yes, then what is dx? Minus cos theta d theta. What is dy? Sin theta, it becomes, sorry, minus sin theta is, okay, differentiation. Yes, this is cos theta, that is d theta. Also what is z? Z is equals to y square, then which implies that z is equals to y is what? Sin theta, then it becomes sin square theta. Then what is dz? 2 sin theta cos theta, then d theta. Therefore theta varies from, theta is equals to 0 to theta is equals to 2 pi. Yes, theta is equals to 0 to theta is equals to 2 pi. Therefore equation 1 becomes, so next here I'll write. Therefore integration over closed curve C f dot dr is equals to integration from theta is equals to 0 to theta is equals to 2 pi yz. Y is sin, z is sin square. Y is sin theta into sin square theta. Then dx is minus sin theta d theta plus yz is done. Then zx, z is sin square theta, x is cos theta, z is sin square theta, x is cos theta, and dy is cos theta cos theta d theta plus xy dz. X is cos theta sin theta and dz is 2 sin theta cos theta d theta. Okay, so that is nothing but integration theta is equals to 0 to theta is equals to 2 pi. This becomes minus sin raised to 4 theta. Next this is plus sin square theta cos square theta, and this becomes 2 times sin square theta into cos square theta into d theta, right? And its simplification is theta is equals to 0 to theta is equals to 2 pi. This is minus sin raised to 4 theta plus it becomes 3 times sin square theta cos square theta into d theta. Okay, its value is 0, so therefore integration over closed curve f dot dr is equal to 0. Okay, so directly if you want you can you'll get the answer by using what, that is calculator. Yes, you can very easily verify. So how that will be, answer is 0. Otherwise you can use the reduction formula. Okay, by reduction formula this its answer is found to be that is 0, right? So this is how one can do examples on, that is the Stokes theorem. And one more example is there, that is verify the Stokes theorem. Verify the Stokes theorem means what, that we so far 2 examples whatever we solved, so that we have done by using what, this LHS, right? That means f dot dr we found, and we found that's what from where to where your curve is varying, and we found the answer. But in the verify, so what you have to do is you have to simultaneously you have to find what, that is LHS and even RHS, and both are found to be equal. Then that is a verification of, that is what, the Stokes theorem. Okay, that the solved notes is given, you can very easily see that. Okay, so the last concept of this particular unit is, that is Gauss Divergence Theorem. Okay, we've seen Green's theorem. Okay, and now we saw the examples on, that is Stokes theorem, and the last concept is, that is Gauss Divergence Theorem. Okay, very important theorem, that is Gauss Divergence Theorem. We'll see the statement and later examples on this Gauss Divergence Theorem, right? So now Gauss Divergence Theorem. Gauss Divergence Theorem. Gauss Divergence Theorem statement. That is, if f is equals to f1i plus f2j plus f3k be a continuously differentiable vector field or vector point function, both are the same, vector field in the region E, bounded by the closed surface, yes, then integration over a surface yes, f dot n cap ds is equal to integration over a region E, that is divergence of f dot dv, right? So here very important, it is not a single integration. So here dv is there means what, that is a volume integral. So volume integral means what, that is triple integration over a region E. Region E means that is a what, whatever region E is there, that is bounded by the closed surface. For instance, just to consider, that is what the sphere, closed sphere means what? That is a closed surface. Hemisphere, if you consider, that is an open surface which will be bounded by what? That is the closed curve. But if you consider what? That is whole sphere, then that is what? The closed surface, right? Inside the closed surface there is a region, that means what? There is a volume, okay, there is a what? That is a space you will get, right? So that is what E, right? You can represent it by what? That is triple integration also, triple integration, but instead of what writing dv, you can write dx, dy, dz, right? So now if this is the case, one can very easily understand where n cap is what? Where n cap is, where n cap is the unit external normal vector to the surface, yes. So you can call it as equation 1. Yes, one can also be written as equation 1 can also be written as double integration over a surface, because when it is surface then it is double integration over a surface, f1 dy dz plus f2 dx dz plus f3 dx dy is equal to, that is the divergence of f. You know divergence of f means what, okay? How one can write? That is triple integration over a region E. How will write? Dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z into dx into dy into dz. Okay, so like this also we can write. Yes, so this is equivalent to what? This equation 1. Yes, so now we shall go to what examples on this Gauss divergence theorem, right? Yes, examples. First one, evaluate integration over a surface, closed surface, yes, f dot ds, or it is n cap will be there, otherwise it is capital S you will get, okay? N cap ds I'll write, where f is equals to 4xzi minus y square j plus yz k taken over the cube, bounded by x is equals to 0, x is equals to 1, comma, y is equals to 0, y is equals to 1, z is equals to 0, and z is equals to 1. That's what? The cube with each side is equals to, that is 1. Yes, one can very easily draw the diagram of this particular what? Yes. Okay, so let me have that cube first, solution. So I'll draw that cube first. Yes. Yes, this is y-axis, this is x-axis, and this is z-axis, we'll say, right? So this is your cube. So this is origin O. Yes. So now by which we can find. So this is very simple. One can very easily understand. Your x is running from x equals to 0 to, that is what, x equals to 1, and y is running from y is equals to 0 to y is equals to 1, and z is running from z is equals to 0 to z is equals to 1, right? So for this particular the example, it is better to use, that is what, the divergence of f dot dv, because you know from where to where your x is varying, because already I have given x is varying from x equals to 0 to 1, y is varying from y is equals to 0 to 1, z is varying from z is equals to 0 to z is equals to 1. So instead of using this surface integral, okay, because surface integral is little complicated, because whatever ds is there, we need to project it on either xy plane or yz plane or zx plane. Instead of that, if you use, that is integration over a region E, divergence of f dv, divergence of f one can very easily find. Yes, so that will be more better, right? Let given is now f, I'll write what is f. F is equals to 4x zi minus y square j plus yz k. Yes, we can call it equation 1. What is f1 here? F1 is 4xz, because f1i plus f2j plus f3k. Then f2 is minus y square, and f3 is yz. Okay, so now what is dou f1 by dou x, which implies that dou f1 by dou x is equals to, this is 4z, dou f2 by dou y, with respect to y differentiating, this is minus 2y, dou f3 by dou z, which is equals to, this is y. Okay, so now divergence, there is nothing to worry. Find divergence. Divergence of f is equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by, that is, dou z. All the values are there, right? That is, divergence of f is equals to dou f1 by dou x is 4 times z plus, this is minus 2 times y plus y. That means divergence of f is equals to 4z minus y. This is your divergence. Okay, you can call it equation number 2. Right? Now, what is the Gauss divergence theorem? That will take by Gauss divergence theorem. By Gauss divergence theorem, we have by Gauss divergence theorem. Okay, Gauss divergence theorem is written here, right? So they asked us to find, that is this only. Okay, so integration over a closed surface, yes, f dot n cap ds is equals to integration over a region E, divergence of f into, that is, dv. dv means what? That is volume element, right? So you can keep it as it is, that is equal to, so here we'll write triple integration. Okay, when we need to write a triple integration, when you write dv as dx dy dz, okay, then we need to write, that is triple integration. Triple integration over region E, divergence of f is already there, that is 4 times z minus y into dx into dy into dz, or dz dy dx. That is how we'll write your limits. According to that you can change it, right? That is integration over a closed surface, yes, f dot n cap ds. Yes, so now yes, so you can call it equation number, that is 3. Now we need to write from where to where x varies, where to where y varies, and where to where z varies. Therefore x varies from x equals to 0 to x equals to 1. Similarly, y is also same. Y varies from y is equals to 0 to y is equals to 1, and z varies from z is equals to 0 to z is equals to 1, because it's a cube, right? Cube with each side 1. So therefore, that is in all the in the direction of all the x's, it will be, that is, 1 only. So therefore that is x is 0 to 1, y is 0 to 1, and z is also 0 to 1. Therefore equation 3 becomes, that is integration over a surface S, f dot n cap ds is equals to, so first I'll write x is running from 0 to 1, y is running from 0 to 1, and even z is also running from 0 to 1. Then 4z minus y into, here z is there, therefore first you write z, next y is there, write y, into last is dx. Okay, so yes, okay, simplify this, which is equal to integration over x equals to 0 to x equals to 1, y is equals to 0 to y is equals to 1, integration of 4z, that is 4z square by 2, that means 2z square we can write, minus yz, z is running from 0 to z is equals to 1, this is dy dx, that is equals to x equals to 0 to x equals to 1, y is equals to 0 to y is equals to 1. Now put upper limit, this is 2 minus y, and for lower limit it is 0, leave it, that is 2 minus y into dy dx, which is equals to, again x equals to 0 to x equals to 1. Now integrate this with respect to y, this becomes 2y, this becomes y square by 2, then y is equals to 0 to y is equals to 1 into dx, then integration over a surface S, f dot n cap ds is equals to, putting upper limit, that will be integration x equals to 0 to x equals to 1, this is 2 minus 1 by, yes, 2 minus 1 by 2, yes, 2 minus 1 by 2 and minus 0, not to worry, into this is dx. 2 minus 1 by 2 means it is 3 by 2, keep it outside, then x equals to 0 to x equals to 1, this is dx. Then 3 by 2 into x is running from x equals to 0 to x equals to 1, that is equals to 3 by 2, then this is 1 minus 0, the final answer is 3 by 2, that is f dot n cap ds over the surface S is 3 by 2. Yes. So we'll check the answer. Yes, answer is 3 by 2 for the first example by using, that is what, Gauss Divergence Theorem. The answer is found to be, that is 3 by 2. Like this one can very easily do as many examples as you want, right? So therefore, so here what I'll do is, again I'll consider one more example, and one more, after that there is a last example which will be for to verify Gauss Divergence Theorem, as like what, the Stokes theorem and the Green's theorem, so that you can do homework. And one more example I'll be taking now. Yes, so now example number 2. Example number 2, evaluate integration over a surface S. Simply sometimes they'll write f dot ds, it is capital S, right? That means f dot n cap small s, right? Don't get confused with this, right? N cap is not there. No, n cap is there, but that is capital S. They have included in that. So capital S is nothing but n cap into ds, that is small ds, where f is equals to 4xi minus 2y square j plus z square k, and and S is the surface, and S is the surface bounded by the region x square plus y square is equals to 4, z is equals to 0, and z is equals to 3. So it's nothing but it's a cylinder. It is the cylinder, right? Cylinder from z is equals to 0 to z is equals to 3. Cylinder length of cylinder whose length is 3 units along the z axis, right? So now we'll start the solution. Let first given is f. What is f? F is equals to 4xi minus 2y square j plus z square k. Call it 1. Here what is f1? 4 times x. What is f2? Minus 2 times y square. What is f3? That is z square, right? Dou f1 by dou x is equals to 4. Dou f2 by dou y is equals to minus 4y, and dou f3 by dou z is equals to 2z, right? Dou f3 by dou z is equals to 2z. Okay, so now divergence first we'll find it, right? That is divergence of f is equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Okay, so now put the values. Divergence of f is equals to, this is 4, yes, minus 4 times y plus 2 times z. This is divergence of f. Call it equation number 2. Okay, call it equation number 2. Right. So now take the figures, draw the figures for what that's given. This one. All right. What is that? So here it is. X. This is z. This is y. Yes, so this is a cylinder, okay, and here this is what? Z is equals to 3, and here this is Z is equals to 0. Yes. Z is equals to 3 and Z is equals to 0, right? So now, yes, okay, so given curves are x square plus y square is equals to that is 4, Z is equals to 0 and Z is equals to 3 they have given, okay. So in this particular what that is cylinder, x varies from, one can very easily understand, x varies from where to where? Actually this is 4 means what? That is 2 square. This is circle, right? Radius is 2. That means here it is minus 2, here it is plus 2, right? X varies from x equals to minus 2 to x equals to plus 2. That means, yes, we can write like, and y varies from y is equals to. So you need to think a little bit, right? Here it is x square plus y square is equals to 4 is that, then y is equals to, how will write? Square root of 4 minus x square plus or minus. That means Plus or minus means what? That is negative of square root of 4 minus x to positive of square root of 4 minus x. Okay, that only we need to write. 4 minus x square to y is equals to square root of 4 minus x square. Okay, and z is already given. Z varies from z is equals to 0 to z is equals to 3, right? So now we'll take Gauss divergence theorem. By Gauss divergence theorem, integration over surface S f dot n cap ds is equals to, that is integration over region E, divergence of f into dv. Okay, divergence of f into dv already we have found. That means E divergence of f is 4z 4 minus 4y plus 2z into dx into dy into dz. Already we have allotted what that is limits. So therefore write the limits also. X equals to x equals to minus 2 to x equals to plus 2. Y is equals to square root of 4 minus x square to y is equals to square root of 4 minus x square, negative to positive, right? Then z is running from z is equals to 0 to z is equals to, that is 3. It will be 4 minus 4y plus 2z into dz into dy into dx. So now one by one integration, minus 2 to plus 2. Okay, so here with respect to z, if you integrate, this is, sorry, one more we need, right? Y is equals to minus square root of 4 minus x square to y is equals to plus square root of 4 minus x square. This is 4z minus 4yz, next plus 4z square, but it is z square, and here it is z is running from 0 to z is equals to 3 into dy into dx. Okay, so now which is equal to, putting upper limit, so we'll get x equals to minus 2 to x equals to plus 2, y is equals to minus square root of 4 minus x square to y is equals to 4 minus x square, putting upper limit. 4 3 is 12, 12 minus, this is 12 minus 12y plus that is z square, 3 square is 9, 9 plus 12, 9 plus 12 we can write here directly, 9 plus 12 is 21, okay, into dy into dx we can write. Yes, yes. So now integrate it again with respect to y. Yes, integration over s f dot n cap ds is equals to x equals to 0 to x equals to x equals to minus 2 to x equals to minus 2 to x equals to plus 2, 21y minus 12y square by 2 means it is 6y square, and y is from minus square root of 4 minus x square to y is equals to square root of 4 minus y square into dx. That is nothing but x equals to minus 2 to x equals to plus 2. This becomes 21 times square root of 4 minus y square minus 6 times 4 minus y square. This is one term. Then minus 21 times square root of 4 minus y square. This is minus 6 times 4 minus y square into dx. Okay, so this is minus of minus plus, then these two get cancelled. Am I right? Otherwise we'll elaborate it. Integration from x equals to minus 2 to plus 2. This is 21 square root of 4 minus y square minus 6 into 4 minus y square, minus of minus plus 21 times 4 minus y square, 4 minus x square it is, sorry, this is 4 minus x square, yes, 4 minus x square 4 minus x square, 4 minus x square, 4 minus x square. Okay, x square, x square, x square, plus minus of minus is again plus, that is 6 times 4 minus x square into dx. So these two get cancelled. 21 times plus 21 times, that is 42 times x equals to minus 2 to x equals to plus 2, square root of 4 minus x square into dx. Okay. Yes, and if you put it in what that is integral sign, then that is what odd function, sorry, this is even function, so we can write 42 into 2 square, 42 into 2 into integration from x equals to 0 to x equals to, that is 2, square root of 4 minus x square into dx, and its value is found to be 1, that is 84 into pi. So therefore integration over the surface f dot n cap ds is equals to 84 times pi. You can use calculator for what? That is last integral, right? Because its constant is there, limits are constants, so one can very easily find them, right? Sorry, so 40, somewhere I have made a mistake, yeah, 20, yes, 84, that is correct, 84 times, sorry, in the notes somewhere it is, there is a small correction, instead of writing 82 times pi, we can write 84 times pi, because 42 into 2 is 84, okay, so therefore it is 84 times pi you need to write. So like this, so we can solve many examples on this Gauss Divergence Theorem, right? So one more last example is there on this Gauss Divergence Theorem, that is verify Gauss Divergence Theorem. That means what? You have to prove both LHS side and even RHS side also. So therefore little complicated means what? Very lengthiest, right? Only by using what, that is RHS, if you want to what, calculate very easy. You can see in the Stokes theorem we evaluated by using LHS, but in the Gauss Divergence Theorem we have evaluated by using what, that is RHS. Whichever is simple, so that we will take and we will evaluate. So complicated thing here, complications are more, right? You can see here ds is there, right? ds is there, the many what, by many planes it is bounded. So here there is what, the sphere, there is a plane z is equals to 0, one plane is there, and z is equals to 3, one more plane is there. Altogether we need to what, find by using this LHS, this LHS side. But there is little lengthier and complicated form to evaluate, that is what, evaluate the given example. So that's why it is better you have to use whichever is simple. In Stokes theorem I told you, that is LHS we have taken, and in the Gauss Divergence Theorem we have taken RHS and we found the answer. Yes, so this is the completion of that is last unit of this particular semester, that is vector integration. So this is the end of course. Just you study the remaining examples by seeing the notes. Yes.